Oh, don't stand, don't. Thank you. Yes, please, don't stand. Thank you. Please eat your food. Thank you for coming out. I know it's not easy to come out in the afternoon. I really want to share with you some of the clinical strategies we've been doing differently in my practice and people that I work with and so forth. So as you guys know, we have a problem with many patients that have chronic food sensitivities, autoimmunity, chronic inflammation. We have a growing list of patients that can't eat any foods. They react against everything. They don't know what to do. We know that the model of leaky gut alone is not answering the question. We know like giving patients leaky gut support load and eliminating every food is not solving many of these problems. So what's the next step? What does the research show? What have we been doing clinically? And that's really the focus. So I want to make sure I leave with information that you can actually use in your office. For myself, I always think of myself as a clinician and part-time researcher, but I'm just like everyone in this room. I have a patient in front of me. They're suffering. They're counting on me to help them. I don't know what to do many times. So, you try to do the best you can, make an application, and make a difference for them, right? You want to see your patient come back feeling better. You want to see them be able to interact with family members and their kids and be able to do the things they want to do, right? It's important. So we all have seen people develop autoimmune diseases, get sick, lose their job, lose their motivation for life, lose all the things that are their sense of self. And autoimmunity is a big issue here. So what I want to do is I really want to focus on the gut microbiome today and tell you all the new research with it. So I'm going to, if you guys can forgive me, I'm not going to read slides to you, okay? I have lots of slides, but the slides are there for you guys to have the abstracts for some of the research that I'm going to discuss, but I'm going to pretty much go through a lot of the research abstracts pretty quickly and just give you the key points. But if you feel frustrated if a slide comes up and we're not going through it and reading each part of it, please understand that's not the goal. I want to try to get to the clinical point, but I also want to kind of catch you up if you guys aren't familiar with a lot of the research going on with the gut microbiome and all the different things that have been shown to deal with tolerance. Okay, so what we're really dealing with today, if you look at chronic patients, is that they're losing their tolerance. And in immunology, there's this concept called tolerance. Tolerance is your ability to react against either dietary proteins, which is called oral tolerance, chemicals, which is called chemical tolerance, and then self-tolerance, which is autoimmunity. So we have people, as they get sicker and sicker, they start to lose their dietary protein tolerance, and they start to react against chemicals, and they start to react against themselves, and they have autoimmunity, right? So the rates of autoimmunity today, according to the Autoimmune Disease-Related Association, is more than all the cases, incidences of cancer and cardiovascular disease combined. It is a big deal. And if you guys are working with chronic patients in an alternative medicine model, preventive medicine model, you're probably seeing the patients that have gone through a model that doesn't have much to give them, and they're ending up in your offices out of desperation, or maybe out of just philosophy. They don't want to take medications, and they want to learn how to use diet, nutrition, lifestyle to make a difference, right? So that's like, we're all in the same boat. We're all trying to figure out what we can do for them. So I'll share with you some of the latest research on tolerance, what kind of clinical strategies that were taken in place with that. But I think one of the key things with it is we've really underlooked the microbiome and some of the clinical implications to the gut microbiome. Okay, so let's talk about the gut microbiome first. Very important, right? It's a growing area of research. So in 2005, the National Institute of Health, they put $115 million into what's called the Human Microbiome Project. Okay? Just like, remember, there's a Human Genome Project a while ago? So they did the same thing with the microbiome. But the goal of this $150 million wasn't to do research. It was to create the structure for an explosion of research. They wanted to share all the different methodologies, all the different RNA and genetics testing and metagenomics testing, and create databases. So researchers all over the world can then take from that investment and then do this microbiome research. So there's been an explosion of research looking into the human microbiome. Okay? Now, let's go back and let me kind of give you a map of where it started and where it's going, and then I'll share with you newest research, and I'll try to make it clinical, because at the end of the day, we're all here for one thing. What do we do with our patients when we're back in the office, right? That's the key thing. All right, so when you look at the first major area of discovery in the microbiome was in 1900. There was a guy named Ian Michkinoff, and Ian Michkinoff came with this really crazy idea. He thought the reason that these individuals in Europe that were living in poverty, that were so much healthier than wealthier Europeans, that everything accessible to them, was that they were consuming fermented foods, very high in lactic acid bacteria. And he proposed that maybe lactic acidophilus and bifidobacter and these different compounds in the gut that they're eating from the fermented foods could be what's making them healthy. Well, that was in 1900. He went through into an extensive amount of research in that. In 1908, he won the Nobel Prize in Medicine for that discovery. So the first major discovery on diet and human microbiome was in 1908. That's a long time ago. First probiotic beneficial bacteria can impact human health study, right? Amazing. Then in 1928, Fleming comes along and discovers penicillin, right? Kill bacteria. And then it was kind of a different model. And then from that point on, it seemed like there was a shift in emphasis of trying to populate with different types of bacteria species to really more of the kill bacteria. I mean, it saved lives, and it was a really important, major discovery for everyone. But if you think of it, most people, if you say the word bacteria, do they associate that with good or bad? Bad. Okay, and many clinicians too as well. Like, how do you kill this? How do you kill that? How do you kill this? So where we are now is then what the Human Genome Project has done is they've really looked at gut bacteria species, and they've really kind of changed the model. And as you guys know, with all the different use of antibiotics in livestock and just people using antibiotics all the time, we now have this bigger issue to deal with, which is antibiotic resistance. And how are they treating that now? One of the only effective ways to treat antibiotic resistance, which is FDA approval, is to do fecal transplants. So they're taking microbiomes with people that have healthier gut bacteria and then transferring them into their colon. And that's one of the few things that's dealing with these chronic antibiotic resistance stages. So you see, it's kind of like a circle of kind of mindsets of how things are happening. So with all this major research in the gut microbiome, what do we know now? Let me just kind of give you the big concepts, and then I'll get into the clinical aspects. What we know now is there is no perfect strain of bacteria. There is no it probiotic. There isn't like, we found it, it's lactobacillus, blah, blah, blah. You take that, everything's better. There isn't that. There isn't that strain. There's a completely underutilized aspect of short-chain fatty acids. I'm going to show you some research on that. And I think if you're not using that in your clinical model, you're missing on some of the major breakthroughs that have happened in the past few years. But what we know is that when they look at the microbiome, health is really determined by the diversity of your microbiome. So every single person in this room has different species of gut bacteria. Throughout this Human Genome Project, they discovered about 3,000 new strains of bacteria, and they don't know if it's good or bad, and they don't even know if the word good or bad is the right way to define it. Because how these bacteria interact with each other can have different effects, and it's not just like a good or bad thing. And your host, yourself as a host, plus exposures and your species can have a different effect at different times based on various variables, like your hormone levels, the dietary proteins you eat, the chemicals, various other things they don't even know about that can really impact the outcome and your function of your microbiome. But they do know this. People that have less diverse microbiomes have more health problems, more inflammation, more autoimmunity. So diversity is a critical factor. Okay? Now, diversity of the microbiome takes place from having a diverse diet. What do we do with our sick patients? Stop eating everything you like. Do you like that? Don't eat it. How about that? Nope, don't even look at that. Never again, okay? So I think we have a tendency, we see people on the Leak Gut program are like, get off gluten, get off dairy, get off soy, get egg, and those are like things you have to do. But the point is when you start restricting foods and they go on a limited diet, they tend to find like a few foods they like. I like carrots and beets. I'm gonna have my carrot and beet salad every day. I like to make my salad with these 5 ingredients. I got every color, but I'm gonna eat that every day forever. So that impacts the diversity of the microbiome. Okay, so one of the things that we know where we've been missing things clinically is we're not having oversight of these patients who are putting on these leaky gut diet and making sure they're not just picking a few vegetables that they're eating, because that's then changing their gut microbiome diversity. Does that make sense? Okay. And that's what happens to a lot of people. They're like, fine, I won't eat any of these other foods, but I'll just make it easy. I just like these, and they'll have celery every day or something every day, and that's like their go-to. But that impacts their diversity. Now, the words that are being used in the microbiome research are like, we have found a new organ. There's so many metabolic functions we have never realized that these gut bacteria do. There's so many metabolites they produce. They impact so many different systems, like they impact metabolism, the endocrine system, the immune system, the brain development, your mood, your behavior. Those are all capping with the chemistry that's happening in the gut microbiome, but the diversity of it is critical. Now, in this human microbiome research project they've been doing, they've looked at the microbiome of people throughout the world, and guess which country has the least diverse microbiome? The United States. And we win. And it's like, we're here, and like next, like number 2 is way over here. Okay, so we have like patients that we're dealing with that have less diverse microbiomes. Okay, and you guys realize when all our animal products like milk and cream that everyone consumes in the standard and average population, and meats that are using hormones and all these hormones in our milk and livestock, those antibiotics impact our microbiome. You combine that with inflammatory foods that are processed, like the different versions of new wheat proteins and casein, and then you have high amounts of pesticides being used, which also impacts the health of the microbiome. You combine all that together with a population that doesn't eat much vegetables, you have a microbiome that's not diverse. And when you have a microbiome that's not diverse, you turn on autoimmunity, you turn on inflammation, and you lose tolerance. So you start to react to foods and to environment and chemicals. Okay? And then if you're only eating carrots and celery and that's it, and some glutamine, you're still going to be sick. It's not enough. So let's talk about the application with that. Everybody okay with that? Okay. So let me just go into this slide here first. And I don't want to get into all the details. It might be hard to see some of these letters, but it's just a study that shows the microbiota, then it shows that it makes some end products like nutrients and polyphenols and so forth. So here's a question for you, just to quiz yourself where you're at as your understanding of the microbiome. What does the microbiome do? So if I was the patient and I go, hey, doc, what does the microbiome do? What's the function? Everything, but that's too general. Like, what are the specifics and how do they apply clinically? So let's talk about that. Specifics. Number 1, they make nutrients. Your gut microbiome makes pretty much most of your folic acid, about 50% of the vitamin K, most of the B vitamins, and biotin. And then things like biotin are involved with biotinylation, which is when biotin binds to nucleic acid, it modulates gene expression. Your B vitamins and folic acid help with methylation, acetylation, transfer of 1 and 2 carbon groups. That's involved with all types of gene expression responses. I mean, it's a factory for making nutrients and singles. You're not getting most of your nutrients from taking supplements. Or, you're getting a lot of your nutrients from having a healthy microbiome that's just then synthesizing these nutrients. Okay? You may even be getting most of your nutrients from your microbiome than from your food intake. Like you have to populate your bacteria, and then they're going to make these different nutrients. Another key thing about the microbiome is, and by the way, that's why you can see people that come in with unhealthy skin and look terrible and look that completely malnourished, and they're taking handfuls and handfuls of supplements. They may just have a microbiome not able to actually synthesize the actual nutrient needs they have. Right? So whenever you see that, you should always consider what's going on with their microbiome. When you see someone who looks completely nutrition depleted, or if you guys ever do any of the red blood cell tests where you look at nutrients, like someone who walks in, with supplements, they're taking everything, earthquake, all the supplements they have, right? Falls over. And then you go, we just did your red blood cells analysis for your micronutrients, and they're all depleted. Guess what? Like clinically, it's probably not, they need more. Probably that they don't have the factory to make their own. So that's a major clue that their microbiome may be involved. Another major area of function of the gut microbiome is that it activates most plant compounds and botanicals. Like we think when we take botanicals, they're ready to go and they have their active effects. They don't. Most plant compounds and botanicals get activated by gut bacteria to metabolites that then have effects. Like for example, genistein and diazine from soy, which has had a lot of research done on it. That gets converted by gut bacteria in the microbiome to lactone and enterolactone, and that's what has its effects. Most of the plant compounds they're studying, like different types of adaptogens and ginseng and all these things, they're not active as you take them. They become active when your gut microbiome converts them to metabolites that then have effects on receptors. Okay? So you may clinically have seen patients. They try botanical, have no effect. Someone else takes it, they have a response. Okay, so you have to realize that the effect from polyphenols and plant compounds and different botanicals strongly depend on a microbiome to have an effect. Like, think about the patient who comes in who's completely malnourished but taking every single supplement, who's taking every botanical but nothing's working for them. Maybe the factor there is that their microbiome can't function. And they go, what are you eating? I can't eat anything. You're eating 4 foods. Like, that's right, you have no chance. And you're going, well, let's treat a leaky gut. Well, good luck with that, it's not enough. You need to give them glutamine and hope for, hey, leaky gut, fix those tight junctions, everything's perfect. It's not. So they still have lost their tolerance, they still have less diversity, and that's like the next level. That's the patients we're dealing with. So we have to kind of take a step back and go, how are we failing on these patients from our functional medicine models? We're not applying the research I'm going to share with you, what we can do, okay? Now, the other thing that I want to share with you, the microbiome Also is involved with biotransformation. Just like the liver detoxifies compounds, takes fat-soluble compounds to make them water-soluble through sulfation, methylation, acetylation, oxidation, reduction. Those all take place in the gut microbiome too. So the microbiome is a detoxifying system as well. And so it's very important for many things. And the microbiome has now been shown to really produce metabolites and turn on receptors from end products, and then those things have effects. So you guys have heard the word prebiotic, right? And you guys have heard the word like a probiotic, right? Prebiotic is like a fiber. Probiotic is like taking like acidophilus or something. Well, there are postbiotics. Postbiotics are what your bacteria produce. And postbiotics like lipopolysaccharides and things like short-chain fatty acids and different types of peptides and gut peptides, they then impact metabolism and physiology. So there's a whole aspect of postbiotics and these metabolites and this whole world of metabolomes and all these things that are taking place that are making realize we may be, when we just try to get patients supplements and their microbiome's not healthy, we may not be getting much of an effect from a botanical individual nutrient model. Does that make sense to everyone? Okay. Just the reflection of like, what are we going to do clinically with the patients we have? Okay. This is just a diagram. This is probably a slide that is not anything new to any of you. The microbiota just can be impacted by your environment, by your food, by inflammatory responses, xenobiotics, pesticides. Stress hormones impact the microbiota. Microbiota changes during pregnancy. Hormones have a direct impact on the microbiota. Medications people take, fungicides, all these different things have an impact on the gut microbiota. Now, we tend to look at things like pesticides and environmental chemicals and think, well, the typical model is these toxins destroy mitochondria, they cause oxidative phosphorylation, they uncouple things, and that's like the model. But many of these toxic compounds, they just make the microbiota lose its diversity. It's just the bacteria species can't grow and populate. And when that happens, you become sick. And you develop loss of tolerance, and you get inflammation, autoimmunity. Okay. So what we're seeing with the gut microbiome and the microbiota, some of these papers, I'm not going to read these to you, but it's the next frontier. If you look at the major areas of research, this is where everyone's going at. Everyone's really focused in the research at. I can tell you, there's no medical specialty that isn't doing research in the gut microbiota right now. Neurology, pediatrics, nephrology, cardiology. There's major areas of publication of how the gut microbiome impacts these different types of condition and state, and I'll share some of those with you. And then going into looking at strategies how we support the microbiota can be very useful. Now, it's very interesting when you see treatment applications with the researchers today, you see two types. You see one type going, okay, we found the bad bacteria, let's kill it. And you guys, the outcomes are terrible. And then the other one is, let's just give someone, just try to modify their diet with diversity, and those seem to be more promising. Okay, so we'll talk about the different application with that too. So let's talk about the gut microbiome. So let me give you some background information, some clinical, and then we'll get into more of the clinical applications. I will promise you I will end on time. I know some of you guys have to go back to your practices, so I won't go over, and I won't save the best stuff for the end before you have to leave or something. I'll make sure I finish on time. Okay. Now, the key thing with the gut microbiome is the research that's come out really endorses some of the things that have always been taught in natural medicine and naturopathy. Like sometimes you read these papers in Nature and these major journals like Cell by some of the world's leading biochemists, and you're going, I think a naturopath wrote this. I mean, it's so amazing. So one of the things that we know is when we look at the gut microbiota and the gut microbiome, your gut microbiome has already been primed before you even had a chance. So we know that the gut microbiome can be varied through different aspects of your lifespan and in childhood and adulthood and so forth. So whether you have a vaginal birth, whether you're breastfed, those things have been shown to impact your microbiome for the rest of your life. Okay? So you've already had your microbiome determined, and some of these research studies show this. So let's talk about the lifespan. So if we look at the lifespan from, let's say, we'll start even with a fetus up to someone who's elderly. Let's talk about the elderly first. So in the geriatric research, they know that seniors that have less diverse microbiomes are more likely to be in care, where people need to take care of them. They have frailty, they have to use canes, they're not physically active anymore, they have cognitive decline. So it's almost a predictive model. They can look at someone's gut microbiome and predict that they're not doing much at their age compared to other seniors. And the more diverse they are, the more likely they don't need help, they're not in a home, the people are taking care of them, they're still active, they're still playing sports, they're still working, they're doing things. So that's some of the interesting stuff with geriatric, the microbiome, when you look at the time span. But let's start at the other end, and then we'll talk about kids. So they used to think that the gut microbiome was completely sterile until you were born, and then once you were born, you get exposed to different environmental bacteria, and then you start to colonize your gut microbiome. So that's been disproven. So what they found is you're actually, humans are actually developing their gut microbiome while they're a fetus, that the amniotic fluid is actually providing bacteria to start colonizing the gut microbiome. That's why when they look at microbiomes in pre-births, children, early birth children, their gut microbiomes are less diverse, less healthy than a full-term baby. And the ones that are born prematurely are more prone for infections. And one of the reasons they think that there's increased risk for preterms is that their gut microbiome cannot handle any type of environmental antigens, because there's such risk for infections. So we know that the gut microbiome is being impacted by the mother's microbiome even during pregnancy. So if you guys are doing any prenatal work, preconception work, it's not just folic acid. Like, you really want to start looking at the research going, the mother's microbiome really, really matters. And we'll talk about, and the key thing that matters is their diversity, having a very good species of gut bacteria, and we'll talk about why that's so important and what it does to the physiological pathways. But that's a key thing. So your gut microbiome is, as a human being developed even while you're as a fetus, and then you're born. Now, when a child is born, they're either going to have a vaginal birth or they're going to have a C-section. They can predict in an adult whether they had a vaginal or a C-section from their microbiome as now, an adult. They can look at your microbiome and go, with a strong probability you probably had a C-section. Because that primes your microbiome forever. So there's a critical 3-year window of your microbiome developing. So when a person goes through a vaginal birth, they have bacteria from the vagina inoculate their microbiota, and they have different species. They go through a C-section, there's bacteria in the skin that inoculate the gut microbiome, and then they have a different microbiome. Because from that point on, it's different. It's crazy. And then the first 3 years of life, after about age 3, they start to reflect an adult microbiome. Now, and then in those first 3 years, they're extremely sensitive to antibiotics. And I'll show you some animal studies and what happens with them. Some of these studies you can't do in humans ethically. So we'll show you some animal studies, what they do with the microbiome, disrupting it, and so forth. But like exposure to antibiotics early on has a change in the microbiome that has long lifespan effects. Okay? So have you ever had patients come in and they come into your office, they can't handle any foods, they're autoimmune, they don't know what to do, they can't handle half the supplements you try to give them, they don't know what to do, and then look at their history, they've had ear infections in their entire life, they had a C-section, those things have a tendency to impact their health. Now as clinicians, you don't want to go in there and go, why every single patient's the same, everyone should respond the same, they're not. Or even worse, you try everything on yourself, whatever works or doesn't work for you is what should work or doesn't work on your patients, because your microbiome and your health is totally different than someone else, okay? So you're definitely going to have patients that have primed their microbiome at some point throughout their lifespan, and it's different at this point. And then there's genetics involved too, but genetics are about 1/3 of the microbiome. Now when you look at the genes, they can look at individuals' microbiome and find that there's uniqueness in genes between your parents and your siblings and so forth, and they can also see in certain regions, there's different microbiome influences, right? So there's different bacteria that you can see if someone is in South Africa or someone is in London or someone is in, Irvine. There's different bacteria species from the water and exposure to pathogens and so forth that's there. So that's useful, but there's not an inclusive thing that it's all the same, and there's a lot of diversity there. Even with genetics, there's a lot of difference there. So the microbiota is changing. It's really critical. Another key thing is breastfeeding. So it's pretty clear with all the major research being done on the microbiome, there's no comparison between formula and human breast milk. There's dramatic diversity developed when children are breastfed that you cannot get with a formula. And before, they didn't know that really meant anything. Now they know that means everything with the health and future of the lifespan. And they've also found, for example, like if someone has a C-section birth, they're immediately primed to have more Firmicutes and Bacteroides species for the rest of their lifespan. That's the pattern they're associating with the risk for obesity. So there you could be like things like risk for obesity and diseases that they haven't discovered yet that could be impacted by how the microbiome is primed. Okay, so those are things to understand. That being said, here's what they also know with all the research being done. The microbiome can change within 3 days. Your diet can change your microbiome. Okay, so the more plant fibers and plant fibers you eat, the more diverse it is. But like if you get depressed and you start eating Cheetos and start watching Netflix and I don't know, whatever you're watching, like what show is the cool thing now? Game of Thrones or I don't know, whatever the one's over. If you start doing that for like 3 days, your gut microbiome will be different. So if you stop eating vegetables and have plant diversity, your microbiome changes. You get into an inflammatory state. So now, after like episode 24 of season 6, and after the Cheetos being done or whatever you're doing, like your body hurts, you ache, your brain doesn't work. You've changed your microbiome. Okay. At the same time, you go, hey, I just want to eat lots of healthy foods, and what am I doing here? And physical exercise and activity change the microbiome. So the microbiome is dynamic, it always changes, so it's not like just because you had a C-section, you're forever going to have problems. It just means there's some changes that have impacts on your health, okay? And some people have to work harder. As you guys know, some patients will have to completely stay on their diet and have to always support their gut to get through the day. And other people, they get through an inflammatory state and function better, and then they change some lifestyle things, and they're okay. So there's different potentials for each patient. They're not all going to be the same. That's just the key thing. So these are just some abstracts that really show, that just kind of summarize the things I was just telling you about. You guys can look at those papers if you're interested in them. This is one of these animal studies where they gave mice low-dose penicillin, which induced obesity, compared to mice that weren't getting penicillin. And then they had these obese genes in their microbiome turned on forever, throughout their lifespan. So, and again, this is, that's not a human study, but it just gives you some idea how important the microbiome can be. And this is a slide that then goes into when you get mucosal immune responses, you can end up with SIBO and loss of tolerance, intestinal permeability. I'll talk about these more clinically just to make sure everyone's on the same page. But when people have dysfunction in their microbiome, they're not going to come into you and say, I'm here to see you because I want to improve my microbiome diversity. They're coming in, I have bloating, I have headache, I don't feel well, I'm totally depressed, I hate everything, I hate you too. Just help me, wherever they're at. You don't know. They come in with their dysfunctions and discomfort and where they are in their life, and they're trying to get through it. And we have to realize there is no specific symptom for a microbiome dysfunction. Do you know what I mean? You have to realize that just fatigue and depression and chronic headaches and exhaustion, they can be related to the microbiome. They don't even come in with GI complaints. Okay? But if they come with GI complaints, it's screaming to you to at least consider that part of it. Okay? And there's some brochures we do which talk about different strategies and so forth, but I'm going to get to the clinical application a little bit later, but I just want you to know we have some strategies for you. Okay, so let's talk about obesity and the gut microbiome. So this is profound information. If you read some of these diabetes researchers, they're saying this is the most exciting thing that has ever come out in the world of diabetes research about how gut bacteria can promote diabetes and how treating the gut can reverse it, and just fascinating stuff, okay? And how your microbiome can totally impact how you process energy. So when people have lack of diversity in the gut microbiome, they harvest more energy from the same calories. You guys understand that? So if you give, this is what they've done with animal studies, and this has been applied into human studies, but if you give the same exact calories to a diverse microbiome and a non-diverse microbiome, the microbiome that doesn't have diversity will produce more energy, which leads to more triglyceride and fat production than those that have less diverse microbiomes. You know the model, like people always say, well, it's all about calories, people are just lazy, just eat what you want, and that's like 80s talk. If someone tells you it's all about calories, what you eat, and that, just tell them to go back to the 80s, put on the Michael Jackson Thriller album, put on a Beat It jacket, watch MTV videos, and then live in that world and play Atari, okay? Metabolism is much more complicated, and the gut microbiome is where a lot of this research is coming in with. Now, when you look at the genes are about 1/3 of the effect, but genes are expressed differently, even with the same family, based on their environmental triggers and their exposures and how their microbiome changes. This is a really important diagram. Let me show you this. Okay, let me give you a key clinical concept. One of the major areas of breakthrough with clinical applications, the most underutilized, the most effective way to help with tolerance issues is to have intestinal butyrate. Butyrate is the key thing. Butyrate. Short-chain fat, not just butyrate, short-chain fatty acids. Butyrate, acetate, propionate. They're all critical, and they're all involved with cell messaging pathways. Okay, so let's go back to diversity and kind of explain how this all works, but that's the key concept. So you guys see in this illustration, maybe it's a little hard to see in the back, but this is normal microbiota, and it's like all these different colors. And then they have like unhealthy microbiota, it's just one color. So the colors represent bacteria diversity, just so you understand this illustration. You guys with me so far? Okay. So the more diverse the gut bacteria are, the greater potential they have to produce butyrate, which is, or I'm sorry, not butyrate, but short-chain fatty acids. Butyrate is one of the three short-chain fatty acids: acetate, propionate, and butyrate. So short-chain fatty acids are then produced. Everybody with me so far? Okay. Now, the more diverse your diet, and we say the more diverse your diet is, we mean plant sources, not animal protein. Okay. So the more diverse your plant food source is, so different types of vegetables, the more diverse bacteria you get. The more diverse your meat source is, it doesn't matter. So if you eat lamb and fish and chicken, it doesn't make your microbiome different. Okay? But if you eat celery, turnips, beets, whatever, kale, all those things start to make your microbiome different. Everybody with me so far? Okay. Now, the more diverse plant proteins you eat, the more diverse bacteria species you produce. The more bacterial species you produce, they make enzymes that become more efficient in converting those fibers to butyrate. Everybody with me so far? Okay, or short-chain fatty acids, I should say. The short-chain fatty acids then fuel making more diverse bacteria. So it's kind of like it supports itself, okay? And that's what you're kind of seeing in the first part of this illustration. They're showing diverse, healthy gut microbiome, making short-chain fatty acids, and just realize these short-chain fatty acids are what you need to have microbiome diversity. Okay? Now, the short-chain fatty acids are fuel for the colon, but they're also signaling agents. This is really critical. Short-chain fatty acids are signaling agents, and they bind to different receptors. And you can see in here, they bind to what are called G-coupled proteins. They're G-coupled protein 41 and 43. These have profound impacts on metabolism. So I'll go through each of these really quickly so you understand these connections. First of all, short-chain fatty acids bind to these G-coupled proteins, and they turn on a peptide in the gut called gut neuropeptide PYY over here. Do you guys see that? That's what controls appetite. Okay, those peptides impact hypothalamic satiety centers, and you then determine your appetite. You know what happens? We don't have a diverse gut microbiome. You're always hungry. You're never satisfied. Now, you guys, we're going to clinically talk about taking short-chain fatty acids as a supplement in protocols. Apex is a short-chain fatty acid product called Enterovite. When we talk about clinical applications, I'll talk about that. But when you take oral short-chain fatty acids, guess what happens to your appetite as soon as you take it? You just feel satisfied. And you're also making your energy metabolism more efficient. I mean, you'll notice it right away if you've never taken it before. I mean, it turns on this peptide in the gut, and it turns on your enzymes for metabolism efficiency and so forth, okay? I mean, immediate, like the first hour, you take it, okay? Now, that's one part of short-chain fatty acids. Now, short-chain fatty acids also come in, and they bind to a receptor. You guys can see over here, this receptor, this fasting growth-like factor receptor over here, and this fasting growth-like factor impacts lipoprotein lipase, and this lipoprotein lipase is used to burn body fat. So it makes the short-chain fatty acids allow the metabolic system to be more efficient in burning fat for energy. Okay? And when your microbiome is not as diverse, you don't get to turn on this gut fat burning efficiency pathway. Short-chain fatty acids then also come in, and they directly impact liver and muscle AMPK pathways. AMPK pathways are the pathways that impact insulin resistance and process your fuel efficiency. So what they find with individuals that have the obese microbiotas is they have no diversity and no short-chain fatty acids, or comparatively different. Okay? And I'll show you some of these studies in a second here, but what do you think happens when they take short-chain fatty acids? It changes everything. It changes their insulin resistance, changes their obesity, changes their fat efficiency, changes their metabolism. It's pretty cool, okay? So we've all seen that too. We see patients change into a plant compound. They do a detox. What are the key things they do in a detox? They start eating lots more vegetables, okay? But clinically, you can use short-chain fatty acids as a supplement. I'll show you some research on that. So it's another tool I think have been completely underlooking in the functional medicine world. Now, short-chain fatty acids are very effective for this. The other thing that they do you guys see this thing, peptide here? It's called glucagon-like peptide 2. Short-chain fatty acids bind to that, and you know what this peptide does? It makes tight junction proteins. It actually makes tight junction proteins. I'll show you some research on that in a few slides here. So butyrate makes your tight junction proteins, changes your metabolism, and there's some other research that it does, that these short-chain fatty acids also impact dendritic cells and regulatory T cells in the gut. It's one of the most powerful pathways you can support when you're dealing with the chronic multiple food sensitivity, chronically inflamed, autoimmune patient. Okay? And even patients with diabetes and slow metabolism, less diverse microbiomes. So anyways, these are the main pathways here. And then when they find that the microbiome is not diverse, it's not making butyrate, none of those effects take place, and there's actually a tendency for inflammation. So those pathways all get hindered. Now, in the microbiome research, they've done these studies. I don't know if you guys have seen some of these. They take microgut bacteria from obese mice, and they give it to skinny mice, and skinny mice all of a sudden become obese. And then take skinny mice microbiota to obese mice, and they become thin. So they've done these animal studies. Well, guess what? They just did a human study in the Netherlands. 18 adult male diabetics, overweight. And they did fecal transplants from lean individuals, and guess what happened? Within 6 weeks, insulin resistance went away, they lost weight. Within a few months, everything came back. Bummer. Because they were thinking they were going to have like fecal transplant centers all over, probably for sure, Newport Beach. Beverly Hills, Newport Beach, eat what you want, go get your fecal transplant, and then you're good. Okay? That's not going to happen. So what they're realizing is you have to have the diet change, you have to have the lifestyle change and really change your microbiome. You can get a short effect, but it really shows that your microbiome has a huge impact in diversity, and a sudden change to your microbiome can immediately change your metabolism. Okay? So it just shows you how impactful the microbiome is. This is just an abstract that just goes all different pathways it involves. So appetite, hunger, inflammation, your insulin control, how you burn body fat, have a lot to do with your microbiome's ability to make short-chain fatty acids. Okay? And diversity is the key. So one of the things, I'll tell you a couple things I do clinically now that I've never done before. Because again, for me, it's all about what do I do with my patients? Like that's the ultimate thing. Like I wake up, that's my thought process, right? I'm not thinking, I got to get this paper published tomorrow. I'm thinking, I have to figure out what to do with whoever that patient, just like most of you. So I use a lot of short-chain fatty acids in my practice now. I use Apex and Terravite really to churn out these pathways. As I show you more research on that, I think you'll see how important that is. And the other thing that I do is I have patients use a Vitamix. And the Vitamix being, you can blend vegetables in. Not a juicer, because I don't want the juice, I want the fiber. So I have them go to the health food store and get as many different vegetables as possible, like turnips, beets, carrots, celery. Cut them all up, put them in a bin, put them in a Vitamix, put some water, mix it. Doesn't matter if it tastes like hell, just drink it. And then there's your microbiome diversity. Okay? Now you add that with Enterovite and fuel because they're going to take the plant fibers and start to have the chance for diversity, and then you fuel that with butyrate, you're going to see a huge change. Okay? So that's one of the key protocols that I've done in my practice. It's been a game changer, dealing with chronic leaky gut in these people. So the kind of vegetables you use are as many different ones as you can. So you just tell the patient, try to pick vegetables you normally don't eat because you want diversity. Pick the ones, here's a good way to do it. Pick the ones you don't like. And if you run out of the ones you don't like, then go to the Asian market and find the ones that look like aliens you've never seen before, and then mix those up. And then make it as diverse as possible to what you're not used to then encourage different bacterial species in your gut. So I do that, and then I throw in the Enterovite as a strategy. That's been a huge clinical pearl for me to share with you. Okay? Yeah, and aliens. Now, anyways, so those are some abstracts here that go into some of the things we talked about. Now, look at this research as we talk about metabolism and so forth. So the gut microbiome in normal, healthy women changes in the third trimester. So what do you think happens in the third trimester to the gut microbiome? So hormone fluctuations can impact the gut microbiome, which is very fascinating. So in the third trimester, the microbiome of a healthy, normal female turns into the microbiome of an obese individual pattern. normally. And the thought is that's healthy. You're supposed to harvest more energy from your calories to help develop and produce a child and get more body fat so you can then have that for breastfeeding. So normally, the microbiome changes with hormones and turns into an obese microbiome in pregnancy. That's what should happen. Because if that doesn't happen, you're going to have a person who's underweight and that has major risks. Okay? So the gut microbiome needs to change. Now, when you see this, you have to think about the patients that we all see that say, ever since I had Bobby, I've never had the same metabolism. Ever since I gave birth, I've never been the same. So maybe part of that question could be in the microbiome has never reestablished. I don't know. I mean, there's lots of different factors. It could be endocrine, could be other factors, but maybe the microbiome is part of the picture. I don't know. But something to think about, right? And do they have the diversity? And we'll talk about some clinical application with that in a second. All right. So you guys see how powerful this microbiome is with metabolism. It's changing everything, how we use calories, how impactful that is, how it controls insulin resistance. Those are all major things, okay? Now, the key point with that was that the bacteria diversity. So let me go over that one more time. As you eat more plant compounds, more compounds make more bacteria species. As you make more bacteria species, those bacteria species make more enzymes that are more efficient in making more butyrate. The key thing is to make not just butyrate, propionate, acetate, to make more short-chain fatty acids, okay? Now, the clinical gem, I just want to make sure you guys consider having people eat lots of plant fibers. Maybe a Vitamix is I find that a good way to do it. Add that with short-chain fatty acids as a supplement. You can use Apex and Teravite. That has propionate, acetate, and butyrate. And I think levels that we figured out were the best ratios for those different subfractions, short-chain fatty acids. So that's one of the things that we use. Okay, now let's move on and talk about the gut microbiome and brain. I'm going to show you guys an animal study. If it doesn't make your jaw drop, I don't know, I should just leave, because this is like mind-blowing. Just drop the mic. I'll see you guys later. Sorry, couldn't interest you. Okay. This is an animal study, and here's what they did. On the left-hand side, you guys see SPF. That means they're specific pathogen-free, which means they didn't give any pathogens to the gut microbiome. It's basically a normal gut. The mice were exposed to the environment and they produced bacteria like they normally would. So just think of it as a normal microbiome, SPF. And then GF, it's not gluten-free. It's germ-free. So these mice were totally sterile. They never let their microbiome populate with bacteria. They never have any diversity. So you guys see the difference between the left and the right? One is normal gut bacteria exposure, and one is germ-free, sterile. So then they did different types of scanning to look at their neurodevelopment. The areas you see lit up is normal development. You see the difference between neurodevelopment. These are the orbital frontal areas and the anterior olfactory area region. They're completely different with different microbiomes. And then they did this analysis here of the whole population study, not just an individual image, but major differences in neurodevelopment without healthy microbiome. And they did all the different regions of the brain, like the basal ganglia, the hippocampus, the striatum, and they found the same thing consistently all throughout the brain. So they concluded that there's messenger signals sent from the gut microbiome to the brain to then help with neuron migration and neuron plasticity and neurodevelopment and all the things involved with developing a brain. Fascinating, right? Okay. Think about autism for a second. Think about learning disorders. So some of the stats say somewhere between 1 in 9 children, 1 in 7 children have a developmental disorder. ADD, ADHD, autism, Asperger's, something along the developmental disorder chain. Its numbers are scary. Now, have you had some patients where they have several, like a mom has several children with autism? Do you think there's a possibility that their microbiome could be a factor? I mean, something like this has to make you start thinking about, are those connections there? I mean, we don't know yet, but it starts to make you think about those. We know with that question, autistic children have non-diverse microbiome, but we don't have the research where we look at the mother's microbiome and see what's happening, okay? So the microbiome is a critical part of it. And when these autistic kids go, all they eat is wheat and milk. Not only is that inflammatory, but you guys, you're not going to build a microbiome with just those two protein sources all day, right? And when you have parents go, well, I can't get anything besides pizza and mac and cheese, well, you're not going to make the microbiome diverse. It's a factor. That could be an issue there. Now, when we continue to talk about the brain-gut axis, let me just say a couple things with you. The brain-gut axis it's not separate. I mean, the brain, gut, they're actually anatomically connected. Do you guys remember anatomy class? So if you actually, I used to teach brain dissection for a few years at Pasteur. So one of the things we did is when you dissect the brain, you just cut the skull and then do laminectomy and cut the cord. But if you flip them over and then take the anterior spinal, if you take out the trachea and the cord and all that stuff, and then you cut through the rest of the spinal cord and you get the brain stem, you can see the whole brain stem. You can see the vagus go right to the gut, and you can see the gut go right into the vagus. You can literally put your hand on the brain and go, ooh, brain stem, ooh, gut, ooh, brain again. It's all one tissue. Okay? So remember, the vagus communicates with the gut communicates with the vagus. There's neuropeptides, neurochemicals that communicate back and forth through those canalized anatomical pathways. There's also pathways that are non-canalized, like neuropeptides, neurotransmitters, cytokines that are in circulation that impact the blood-brain axis. So these things communicate. Everybody okay with that? Okay. So the pathways from the gut to the brain are not mysterious. They're pretty straightforward. Okay. Now, there's some studies where they looked at behavior. So in this one study, they take mice, they give them a cocktail of antibiotics, and it changes their behavior. They get all anxious and nervous compared if they didn't have the cocktails. And here's another interesting part of this study. I'm just clicking to this diagram here. So there's different types of mice. So let me show you what they did. There is the NIH Swiss mice, which is very courageous, explores all over the place, doesn't sit still, is always moving around. If you put it somewhere, it's going to be checking everything out. That's just their behavior. And then there's the BLB mice, and these mice are timid, they're scared. If you put them in a room, they'll hide in a corner and don't want to go anywhere. That's their behavior. That's just how they are. It's a species. So they take the microbiota from the timid mice and they put it into the aggressive, courageous mice, and they take the microbiota from the courageous mice, and guess what happens? Their behaviors completely switch. Wow. So the microbiota completely changes their behavior. Just from this is pretty quick. They colonize them, and then right away they start to have different behavior changes. Right? So your gut microbiome can impact you as well. And you guys see patients that have unhealthy guts and they have no motivation, no drive, they don't want to do anything, everything sucks in life. They get healthier, everything's great, they want to do things. It's a big deal. So I think we underestimate the impact of the gut on the brain sometimes, or we forget. And then they also did a study, another part of the study where they put Campylobacter jejuni in the water to infect and inoculate these mice. And these mice changed their behavior. They became very cautious. And if they only had the water, they were just playful into the maze and no effect. This is, again, showing how a change in the microbiome can completely change behavior. Amazing stuff, right? Okay, so, fascinating. Now, another part of research is just this whole brain inflammation thing. So you guys heard in functional medicine, gut on fire is brain on fire? Okay, that is clearly being shown to be true with all the major research coming out. Okay? So if there's inflammation in the gut, there's inflammation in the brain. Now remember, the inner gut microbiota has no pain fibers. There's no nociceptors in the inner gut mucosa. There's nociceptors in the outer fibers. You can have pressure against your gut and feel discomfort and pain, but your inner gut microbiome has no pain. So when there's inflammation, you don't know it. The brain has no nociceptors. The gray matter or white matter, there's no nociceptors. There's pain fibers in the vascular system and around the dura, and not the dura, but around the vascular structures, around the tissues, around the brain. But the actual brain itself, the gray and white matter, have no nociceptors. Gut on fire, brain on fire, has no symptoms of pain or discomfort. You just lose function. You just lose function. Can't think, can't focus, get brain fog, can't concentrate. Another major cause, a major cause of chronic fatigue in patients is that it's brain-based. You go to patients and go, hey, are you tired? Yes, all the time. I have such chronic fatigue. I've checked my adrenals. I've checked my blood sugar. I've done all this. I'm still tired. Okay, what makes you tired? Does reading make you tired? Yes. Does driving make you tired? Yes. Does being on a computer make you tired? Yes. So you're telling me a cognitive task makes you tired? Yes. Does talking to me make you tired? Absolutely. We have some patients, I don't know if you've seen this, like you're doing history with them and they literally lie down. You ever seen that? You're doing history, they just lie down on the ground. Or if you have a table, let's just go on the table and just lie down. Can I do it from here? You're like, sure. And you make notes. Endurance, brain, issue. Okay. So a lot of times when the gut's on fire, brain's on fire, you're going to have brain fatigue issues with patients, right? And they're not it's not general metabolic fatigue, it's just this brain-based fatigue. So always think about brain inflammatory responses. Now, lots of papers have basically shown if you have inflammation in the gut, you start to show up with white matter lesions. This was a study that was published. They showed like 42% of 42 or 46% of inflammatory gut conditions start to show white matter lesions on MRI. Here's what you have to understand with MRI. You have to have 60% to 70% destruction of the myelin sheath to start showing up as focal white matter lesions on an MRI. So if you have 30%, 20%, you're not going to see focal white matter lesions. So they're showing over 40% of subjects with inflammatory bowel disease when they do an MRI have these white matter lesions. It's pretty scary stuff. So inflammation in the gut seems to be directly linked to inflammation in the brain. Lots of different papers have shown similar things and these white matter intensities. So that's a key takeaway. Inflammation in the gut impacts inflammation in the brain. Now, you know what causes major inflammation in the gut? Here's the thing. It doesn't have to be an infection. It doesn't have to be a food sensitivity. A major pathway that causes inflammation in the gut is lack of short-chain fatty acids, lack of gut diversity. If you have that, you will have an inflamed gut. Okay? So the person that's coming in, only eating a few vegetable proteins, not making enough butyrate because of that, doesn't matter if they're taking glutamine and leaky gut support because they have loss of diversity. Loss of diversity also causes inflammation, which causes intestinal and leaky gut. So you could be chasing the leaky gut and totally forgetting about how important the short-chain fatty acid part of this mechanism is, and then not have any success. And they're just already upset because they have to cut out gluten. Oh my God, everything has gluten. What am I going to eat? Or milk. And so the fact they're just eating a few vegetables and that's what they can do, and don't make it any worse than that, like making them eat turnips, something they hate, is another factor we don't address that can make the patient not reach where they need to reach. Everyone okay with that concept? Okay. Another major concept is if the blood-brain barrier breaks down, if the intestinal barrier breaks down, it's very likely that the blood-brain barrier breaks down. So this is where a lot of the research is going. They're intimately connected, the tight junction proteins between the blood-brain barrier and the gut barrier are involved. Because then once the gut barrier breaks and then the blood-brain barrier breaks, you have serious risks for neurodegeneration, inflammation, autoimmune diseases of the brain. It's pretty scary. And what they're finding, there's some recent papers published where they showed brain autoantibodies are much more prevalent than people ever thought. And lots of people have circulating brain antibodies, like myelin and so forth, if you check the normal population. And we've done that in a study that we're doing right now. It's scary, okay? I would say about a third of people, if you test, have maybe some brain antibodies. That becomes a problem when they break their blood-brain barrier. So when they lose their tight junctions, and again, they don't have to lose their tight junctions because they had an infection or a food protein. They can lose their tight junction because they don't have enough short-chain fatty acids from lack of diversity. When that takes place, that creates the whole sequelae of these disorders. Okay, so those are the key connections between the gut and the brain. Now, in the field of cardiology, they're also finding some connections between gut bacteria and cardiovascular disease. So let me share some of these with you. So here's a diagram. This is a diagram Dr. Vajani made, which is beautiful. And here what you see is a summary of what these papers published on this topic are showing, that some people have these different bacteria species in their gut, and they have these bacteria species in their gut. When they get exposed to red meats and animal products, those animal products have L-carnitine, and the L-carnitine mixes with these bacteria, and these bacteria make an end product called TMAO, and then TMAO directly destroys the blood vessels. So the impact of like red meats and saturated fats and animal products could be totally different on individuals based on their gut microbiome. For some people, red meats and animal products can be very inflammatory. For other people, it may not. And one of the mechanisms they found with the microbiome research is that there's bacterial species that can promote the vascular destruction. Fascinating stuff, right? So now they've been measuring this TMAO level in blood. They can measure in blood and see if it's high. And they think that could be a future marker for looking at heart disease as a general screen, like cholesterol. And they've tried to use antibiotic therapy to treat and kill these bacteria to bring TMAO levels down. Doesn't really work. Short effect, and then it doesn't work at all. Okay? So it goes back to making more diverse bacteria species to then mitigate some of these responses. Now they also find that this TMAO pathway binds to G-coupled proteins also in the vascular system, and it causes hypertension. And also causes vascular injury and impacts the glomeruli of the kidneys. And now you have blood pressure mechanisms and vascular endothelial destruction mechanisms from influence of the gut microbiome based on eating animal products. So some people have different microbiomes. They eat red meats, They don't have these reactions. So again, like the microbiome is then to be a central theme with a lot of these pathways that they're figuring out. I'm so glad they've spent so much effort into studying this now. It really makes us understand some of these conditions more. Very fascinating stuff. And there's also research that shows when people start to actually get heart failure, they lose their cardiac output, and as they lose their cardiac output, they can't get blood flow to the gut, and they get leaky gut. And then they get leaky gut, and then releases LPS, lipopolysaccharides, and that destroys the vascular endothelium more. So they get this vicious connection between cardiovascular disease and the heart. Fascinating stuff, right? So maybe you look at people's gut microbiomes, your diversity, TMAO levels, make sure they don't have LPS in their system. LPS for sure is a vascular insult. In several papers now that have shown that pathway. Okay, so interesting stuff. So let's talk about LPS for a second. LPS, so remember postbacteria? Postbiotics? So lipopolysaccharide is a postbiotic. So bacteria makes these compounds called lipopolysaccharides. Some lipopolysaccharides are healthy, some lipopolysaccharides are very inflammatory. The gram-negative lipopolysaccharides are very inflammatory, okay? So when a person gets breakdown of their tight junctions, and remember, leaky gut doesn't have to be caused by an infection or stress depleting the gut. It just can be caused from your depletion of butyrate, propionate, and acetate in the gut from lack of diversity in the diet. Which is, I think we all see that, right? Patients that are taking everything, but a very diverse diet and still sick, and then confused, not knowing what to do. Okay, so the butyrate level, there's butyrate, propionate, acetate being levels low can completely shift that. But once their tight junctions break, LPS reaches into the system, then LPS causes inflammation all throughout the body. LPS turns on glial cells in the brain. LPS turns on inflammation of the vascular endothelium, promoting atherosclerosis. LPS hits joints, causes joint inflammation. It feeds an autoimmune disease that's already there, whatever the target tissue may be. I mean, it's a serious issue. So there's lots of research with permeability in LPS and its impact on things like diabetes in this abstract, and metabolic disorders, and this mechanism of LPS. Now, this is important. The reason I want to share these slides with you is because I'm going to show you guys a panel that includes LPS. So one of the ways we look at the health of someone's microbiome and their gut is we look at LPS levels. And the LPS we're looking at in a lab test is gram-negative LPS, the harmful ones. And we want to see if it's involved in their system. And if it's involved, we know they have tight junction protein breakdown, because that's how you get them into circulation, and also that's creating an inflammatory cascade. I made a slide to show you some of the main research pathways that LPS has been shown to cause. So LPS has been shown to alter insulin receptor signaling, promote insulin resistance, turn on microglia cells, cause inflammation, shut down brain neuron synapses, causing depression. LPS can also cause inflammation in the liver. LPS can impact the mitochondrial uncoupling, which decreases ATP output and fatigue. LPS can impact 5-deiodinase, impact T4 to T3 conversion. LPS can shut down the burning of turn down hormone-sensitive lipase, so you can't burn body fat, so it impairs metabolism to burn body fat. So LPS is a big deal. So if you ever see LPS on a panel, you know it's a big deal. Their gut microbiota is unhealthy, and their tight junctions have broken down. Okay? So let's talk about applications clinically. So we talked about short-chain fatty acids quite a bit, right? So the key concept was this. As you diversify your gut by eating more diverse plant-based foods, you get more bacteria, diverse species. Those diverse species have more enzymes. The end effect being a diverse group of bacterial species have now more potential to make higher amounts of butyrate. The higher the butyrate, the healthier these pathways are in the gut. As the gut makes butyrate, propionate, and acetate, the short-chain fatty acids, these short-chain fatty acids have two main functions. One is fuel. They then allow the bacteria to have biosynthesis to make the gut more diverse, which is a good thing for health. And remember, the bacteria species, they're also involved with making nutrients, folic acid, vitamin K, helping have enzymes break down plant compounds and botanicals and polyphenols. So diversity, the more diverse the bacteria is, the more metabolic processes you have as your health potential. Okay? The second thing that short-chain fatty acids do is they're signaling agents. They bind to receptors, like I showed you guys, that G-protein coupled system. So the good thing is that the short-chain fatty acids really don't promote unhealthy bacteria. Unhealthy bacteria, you guys want to promote it, you eat a lot of sugar. Okay? You want to make your microbiome healthy? Get off the short-chain, get off the sugar, and take a lot of butyrate and eat a lot of different plant fibers. Very easy, okay? So they impact in the gut Treg cells, and they also downregulate the inflammatory cytokine response. Now, This is a paper. It just shows you that the main fuel source is butyrate. Okay, so you guys all know glutamine, right? Glutamine is a fuel source for the small intestine. Butyrate is the fuel source for microbiome diversity, not glutamine. Glutamine is good for the leaky gut patterns, tight junctions, but you need butyrate to provide the fuel to have microbiome diversity. Okay? They're used by the epithelial cells, 70%. Now, if you guys start to use short-chain fatty acids like Enterovite, here's what you'll notice in some people. Some people will take it and immediately have a huge boost in energy. And if you see that, you clinically know that their microbiome is seriously compromised. Okay? So you might want to ask your patients, hey, when you start taking this Enterovite, short-chain fatty acid product, let me know what happens when you first take it. Let me know if it gives you a boost in energy. And if they get that boost, then it strongest makes you clinically think, wow, they have no diversity because they can't make their own. So you bypassed their diversity and directly gave them the fuel. Okay? Now, this is an interesting paper, and it goes into, it says, reduced level of short-chain fatty acids result in metabolic starvation accompanied by mucosal surface degeneration and acute inflammation. You guys understand that? Okay? So as a person has less butyrate production in their gut and the levels of butyrate drop, the microbiome starts to shrink away. You guys ever seen those glacier caps in those glacier areas and they show global warming like shrinking it all away? Okay. That's what happens with butyrate depletion in your gut. Your microbiome depletes away like the ice caps. Okay. So you have to have high amounts of butyrate. Then they go on to show the mucosa recovers when butyrate is supplied. For example, removal of fiber from the diet of rats causes colonic mucosal atrophy, and colonic infusion with butyrate stimulates colonic mucosal growth, replacing the tropic effects of dietary fiber. Now, short-chain fatty acids are involved with energy metabolism, making gut microbiome bacteria, biosynthesis, but they're also involved with blood flow to the gut. Remember the G-coupled protein we talked about with diabetes pathways and energy pathways? Well, those G-coupled protein pathways that short-chain fatty acids bind to also impact the vascular blood flow system to the gut. So short-chain fatty acids also start to increase circulation blood flow to the gut. What do you need to heal a leaky gut? You need blood flow. So people that have intestinal inflammation, compromised guts, they got to get the blood flow there. So short-chain fatty acids not only fuel, but they help increase circulation to the gut. It's a key thing. Now, this is a major pathway in the gut for short-chain fatty acids. So here you can see one of the short-chain fatty acids, butyrate. And by the way, butyrate has its own effects, propionate has its own effects, and acetate has its own effects. That's why when Apex made Enterovite, all three were included in there. You have to have all three to have the global effect of short-chain fatty acids. So many factors that make them, they just make butyrate, and that's not enough. You need butyrate, propionate, acetate. Okay? Now, in this illustration, you see butyrate. One of the things that butyrate does is it inhibits nuclear factor kappa B. Why is that important? Because it's the pathway for all intestinal inflammatory diseases. Crohn's, ulcerative colitis, celiac disease. All inflammatory gut diseases in the colon are via that NF-kappa B pathway in the gut mucosa. So butyrate inhibits it. Yes, cancer. And then butyrate also turns on Treg cells. Remember Treg cells? Treg cells are what dampens the autoimmune response, the inflammatory response. They turn on T suppressor cells. They block inflammation. They block autoimmunity. So butyrate, remember, is not only fuel, it's a cell signaler. It activates and signals cells. It signals the GPR proteins for metabolism, but it also binds to the epithelium, dampens NF-kappa B, and it binds to Treg cells and turns on the anti-inflammatory response. Okay, and this is what this diagram is showing. And then they show here decreased butyrate production, so they have increased adhesion molecules, increased inflammation. So when a person doesn't have high amounts of butyrate in their gut, they get an inflammatory response. Okay? Now, tell me if this patient has low butyrate. You guys ready? Health conscious. Let's have fun. Yoga instructor. Health conscious. Drives a Prius. I'm just being grows their own crops. Meditates. No pesticides. The best soil you can get from like Norway. Highest nutrients. Has their own They use their own stool and make their own fertilizer. Like, beautiful stuff, like the best crops, everything, okay? But they only grow like 3 vegetables. They take handfuls of nutrients and supplements. They don't have diversity of their gut. They take glutamine. They have multiple food sensitivities, and they're wondering why they're not getting better. You have to have diversity to have butyrate. Unrelated to infection, antigen, all the other stuff. Does that make sense? Okay, no one get upset about the Prius thing or anything. I'm just joking. Okay, but you guys understand the concept here with the whole, like, you can be doing everything right, but if you don't have that diversity, you don't have the potential to make butyrate, that alone, and all these research is showing it's a huge thing, okay? And again, that's why we see that discrepancy in a clinical model, when we see these patients that are doing everything right, beyond anyone else in this world, like just really focused on their health, all the things that they should make them healthy, and they're not. And this missing link could be the butyrate. Does that make sense? Now compare that to the guy, let's have fun. The guy driving like the huge truck, burning up all this gas, eats nothing but fast food, eats McDonald's, throws in the back, there's no diversity. Like, you expect them to be unhealthy, right? And just taking glutamine alone is not going to do anything with them. So this is the factor here. Now, do you guys remember this concept of like loss of tolerance? Okay. So when you see a patient that is reacting to every single food protein, that means they've lost their tolerance. Okay, and that's the extreme part of it. So a patient comes in and goes, listen, I don't know what else to eat anymore. Everything I eat to, I start to react to. Or a person that comes in and they do a food sensitivity profile and every food is positive and they react against that. Okay, so that means they've lost their tolerance. Now, leaky gut is one mechanism that can cause loss of tolerance, but it's one of many. And this is why I was saying you can't just focus on leaky gut. The other one is your Treg cell function. If your Treg function goes down, you lose the ability to have oral tolerance. Another main pathway is overactivation of dendritic cells. So dendritic cells are the sampling cells of the gut epithelium. Okay, so as foods come in, they kind of sample it. Right, they sample all the food. Okay, now with people that have lost their tolerance, they're overactive. Okay, so when you see someone's reactive to all these foods, you go, I got to fix their leaky gut, I got to get their Tregs going, right? And I got to turn down their dendritic cells. Well, guess what butyrate does? And short-chain fatty acids. It dampens dendritic cell responsive. Okay? So butyrate conditions, human dendritic cells, prime T1 regulatory T cells via both histidine decalase inhibition, G protein-coupled receptors, and then these short-chain fatty acids have an impact in turning down these oversampling dendritic cells. Look at this title, diet-derived short-chain fatty acids. And that's the key word, diet-derived short-chain fatty acids, stimulate intestinal epithelial cells to induce mucosal tolerogenic dendritic cells. Look at this paper. Look at this title, 2016, published in Cell, okay, reproductive. Dietary fiber and bacterial short-chain fatty acids enhance oral tolerance and protect against food allergy through diverse cellular pathways. And then they show high-fiber diet, acetate, don't forget about acetate, butyrate, propionate. They bind to G-coupled proteins, they turn on Treg cells, they dampen dendritic cells, and they decrease the inflammatory gut response. Look at this paper. Intestinal short-chain fatty acids are linked with diet and human health, and they basically show that short-chain fatty acids have the direct effect. They impact intestinal mucosa, they impact signaling pathways, they create the ideal environment. Now, this is an interesting study that was done in one of the veterinarian journals. So let me show you what they did. They do a cross-section of the gut mucosa. You guys see the intestinal cells here, tight junctions? Then they infect them with an antigen, and within 7 days, they breaks down to this. Do you guys see the one in a second? So within 7 days from an infection. In another group in the study, they give them the infection plus butyrate, which is this. Guess what happens? It doesn't break down as much. So the same infection, coupled with the only thing that did different was add butyrate, completely changed the destruction of the antigen on their gut. Butyrate blocks the inflammatory response. Fascinating stuff, okay? Now look at this paper just published, 2017. Our findings suggest that butyrate might protect epithelial cells from LPS-induced impairment of barrier integrity through the increase in the synthesis of tight junction proteins. Okay, short-chain fatty acids help make tight junction proteins. Remember that GLP-2 pathway, glucan-like peptide 2 pathway? Butyrate directly binds GLP-2. GLP-2 turns on the synthesis of tight junction proteins. We're always worried about trying to get fuel to repair it, and glutamine. Butyrate as a signaling agent turns on the receptor to make them. Okay? Now, Now look at this here. This is an antigen, and they show this antigen is putting out pathogenic end products called LLO. This is in the lumen. They include butyrate with the antigen, and there's less neurotoxic byproducts or enterotoxic byproducts released. So even when people have infections, butyrate and short-chain fatty acids, acetate propionate are very, very helpful for that system. So look at this title, published Immunology 2015. Short but smart. Short-chain fatty acids train T cells in the gut to fight autoimmunity in the brain. So remember we shared all this study on the microbiome is showing that inflammation in the gut is inflammation in the brain. Well, using compounds like short-chain fatty acids turns on these mechanisms that we just have been talking about, like Treg cells and damping dendritic cells and turning on G-coupled proteins and GLP-2 pathways directly. And those things block the inflammatory response that you get from gut and brain. So it blocks down that inflammatory response. And here's another paper, Dietary Fatty Acid Susceptibility to MS, and they go in there and said, short-chain fatty acids should be considered as a candidate for safe, potent treatment as an add-on treatment to those that have MS. 2018 paper published in Multiple Sclerosis. Here's another paper, Dietary fiber acids impact central nervous system autoimmunity via the small intestine, and they show treatment with short-chain fatty acids ameliorated AE, which is reduced axonal damage, long-lasting impairment of lamella Treg cells. So what they found is the use of short-chain fatty acids suppress the autoimmune inflammatory response in the central nervous system. Again, multiple papers like this. If you go on PubMed and just start typing away, you'll see many of them. This was a great paper too, and they used short-chain fatty acids to impact the uveitis. Uveitis is the damage to the uvea, the pigmented area of the retina in the eye. So what you see in this scenario is a normal retina. You can see the damage from the inflammatory response with uveitis. And this here, you see they're given butyrate, and they don't have the same amount of destruction. Butyrate in the gut impacts the inflammatory response in the eye or in the nervous system. Here's a histology slide, normal with the inflammatory response, and then here's the short-chain fatty acids mitigating the inflammatory response in the eye. So your gut short-chain fatty acid levels are much more profound than you may think. I personally have ever thought. Okay. So here's just the pathways that they think are involved here. It's basically shutting down the Th17 pathway. Make sense? So the clinical takeaway is to consider using short-chain fatty acids. This is the formulation that I use in my practice. This is the one we thought had the ideal ratios of butyrate, propionate, and acetate. It's called Enterovite. I use this in my practice all the time. Most of my patients are on short-chain fatty acids. It has been the biggest change in how I work with chronic patients in the past few years. Okay. Now, the evidence is there, and the clinical effects are there. You're going to see some people have great responses with that as in their cocktail and their protocol. There's also a study that was published that short-chain fatty acids can mitigate the negative effects of people that go on antibiotics. So when people go on antibiotics, they take like a probiotic. What if which probiotic are you choosing? Is that the right one? Well, short-chain fatty acids help populate all of them. Right? So why not populate and give the fuel for all of them? Add that in with the dietary blend of different plant proteins, plant fibers, and now you got a recovery state. Okay, so this is one of the key takeaways. If you haven't been using a lot of short-chain fatty acids, it's definitely something to consider, and definitely consider with your patients with leaky gut and all the other things. Now, it's not to say that probiotics are not beneficial. There's plenty of research that shows that probiotics are beneficial, and I still use them in my practice, but without question. I use much, much, much more short-chain fatty acids than probiotics or anything else. And when people get sick, like you have to make a call. How many things you want to give a patient? What do you want to do? And I think if you have some chance to look at the papers that I showed you in your PowerPoint slides, or even go on PubMed and start looking up short-chain fatty acids in the research circle, not on like health nutrition sites, but on PubMed, because they're all major research the past few years. Here's the thing, like major research hits, and honestly, clinical practitioners don't use it for like years later. Like, so read the actual, go right to the source. There's amazing research on this. It's not being used in clinical practice by most practitioners. Like functional medicine, all about the gut, fix the gut. But forget short-chain fatty acids. But it's the most critical, I think, supplement with all the research that's come out. Okay, now let's talk about another key thing, which is glutathione. All right. Because a long time ago, I was meeting with people at Apex, and what's the big vision? What are we really dealing with? What are practitioners suffering with? What am I seeing in my practice? What are the friends I'm seeing in my practice? What do we have to develop to help the population that we're all seeing? And obviously, there's an explosion of patients that have inflammatory, autoimmune, loss of tolerance, leaky gut conditions, right? Gut on fire, brain on fire. I mean, that's the battle right now with so many people that have made all the right choices, but they're still suffering. So and because of that, you've seen a lot of Apex seminars on different topics. We always talk about glutathione, how important glutathione is, and Apex has lots of different glutathione products now, right? They have Oxycell, which is a topical liposomal glutathione. They have acetylglutathione as a glutathione product. They have glutathione recycler, which are all the botanicals that make glutathione. But even having all those, they just recently went to the next step. And because of how important glutathione is, there had to be a way to get high amounts of glutathione into the system that hasn't been done before. So there's now a new product called trisomal glutathione from Apex, and it is a liposomal acetyl glutathione. It's the only one in the market, but it's the most effective way to get glutathione into the system, in my opinion. Okay. Now I can tell you, Apex has lots of products. They have over a few hundred products. The trisomal glutathione is in the top 3 products, in my opinion. Okay, it is very, very effective. And glutathione is critical for the gut microbiome. So why am I talking about the gut microbiome discussion? This is why. So remember that you have to have diversity in your gut to make butyrate, and butyrate help makes your gut populations and diversity. Inflammation shuts that whole thing down. So if you have significant gut inflammation, even if you're eating a lot of plant compounds, you can't have healthy bacterial biosynthesis. So inflammation impairs your gut's ability to make bacteria species populate. Okay? Inflammation causes tight junction protein breakdown, which then perpetuates this whole leaky gut inflammatory gut issue. So there has to be an aggressive protocol, not only to give things like short-chain fatty acids, but to block inflammation. Okay? So there's some information in glutathione here. Most of you guys are familiar with it. I'm not going to go into great detail because of time. You guys can look at these on your own, but basically, here's the bottom line. When there's a decline of glutathione, the mucosa breaks down. Okay? So if your glutathione level reserves in your gut drop, your mucosa breaks down. And you also can't produce beneficial bacteria from things like butyrate. So you have to also block the inflammatory cascade. So what these studies are showing you is that impairment of glutathione synthesis and how it impacts glutathione levels. This was a study that they did it was an animal study they did, and they took animals, they infected them with salmonella to induce leaky gut, and what they were looking for was there any association between glutathione levels. Here's what they found. Once they got the inoculation and the infection, the guts didn't develop leaky gut until glutathione got depleted. So your glutathione status is critical for your gut mucosa, okay? From developing leaky gut and also for reducing the inflammatory response. So these are the different types of glutathione out there. Regular glutathione is not absorbed very well. It's not stable. Like if you ever just see oral glutathione, it's probably it's the least effective way to take glutathione. And then there was some NAC, as you guys know, is a very effective way to raise glutathione. It's a stabilizer, but it's a precursor. It's not actually glutathione, but lots of benefits. And then research later came on and showed S-acetylglutathione was a good way to stabilize glutathione. That's when Apex formulated acetylglutathione, which was a way for us to get glutathione to the system that was more stable than regular glutathione. And then recently they made a liposomal delivery, but not just any kind of liposomal glutathione, liposomal acetylglutathione. Okay? And because of that, I'll show you here. This is the liposome structure. You guys understand the concept of liposome? Liposome is a fat structure, and that it gets absorbed very well through the gut. It also helps get through the cell membrane. And then if you do that in acetyl form, that's the ideal. Now, the reason the product is called trisomal glutathione is because they have, the formulation is a three-tiered approach. They have glutathione itself in an acetyl form, and then it's surrounded by liposome, and there's also N-acetylcysteine. N-acetylcysteine is helpful to make glutathione, but also protects the liposome. Okay? The key thing is getting glutathione to tissues without having to immediately break down and getting it to the cell. So this is the acetyl type of glutathione. This is the liposomal uptake into the cell. Apex made a great animation. Let me show it to you how the liposome works. So that's a liposome acetylglutathione. The liposome allows it to cross the cell membrane. And then it's glutathione with an acetyl group. The acetyl group stabilizes it. So that's the acetyl group. And the liposome has an acetylcysteine, so it's a very effective way to get glutathione. Now, we have to understand, with an emphasis on trying to figure out supplements to help with chronic inflammation, autoimmune disease, and glutathione is so critical, there's been a non-stop effort to figure out how to make glutathione more effective. For me personally, this was without doubt the most major breakthrough in using glutathione. An acetyl liposome glutathione is very effective. Well, so we don't need that. We don't need that. Light turned off. If we have the lights back to normal, that would be great, so we don't have people snoring. Okay. All right. So this is the trisomal glutathione, and the trisomal glutathione is the acetylglutathione in a liposome with the N-acetylcysteine to support it. If you guys haven't tried this, it's definitely one of the things to try. I don't think any people will be disappointed. Now, you guys remember, glutathione is sulfur, and sulfur has a pretty strong taste. But if you guys are here, please sample it, because you guys will see they did an amazing job with the taste aspect of this, to the point where kids can take it. My daughter's 11, she hates taking stuff that tastes bad or smell bad. No problem taking this form of glutathione, okay? And as you know, family's very honest with you about everything, so no problem with the kid test for me. Okay, now, let's kind of skip into some applications here clinically, besides just the glutathione. So let me tell you where we are so far. I wanted to show you guys some of the research in the gut microbiome if you guys haven't been able to keep up with some of the research, and you can see how important it is and how important gut diversity is, okay? And we kind of talked about that. And then what we're realizing is how important using short-chain fatty acids are in a clinical model, and you guys see some great research published on that. And then we also talk about how important glutathione is, okay? Now, that's like two fundamental things. So if you have a really sick chronic patient and you are looking at their mucosal health as a key factor in that, and with anyone who's so sick, you have to kind of figure out how many supplements you give a person. You're always kind of weighing that out because you can't put them on 20 things. You want to use supplements that have the most diverse, broad effect on multiple systems for the chronic inflammation and disease, okay? Glutathione and short-chain fatty acids, without question, are the most effective broad spectrum hitting the anti-inflammatory cascade because of the pathways they hit, okay? So if you hit pathways that hit multiple systems down, you have greater effects than just trying to hit something downstream. So this hits upstream, and you have its downstream effect all the way through the inflammatory cascade. Now, we all know that patients get more complicated. So I just want to also point out the other thing, if you guys are not familiar with Apex and they've organized some things, how they've organized some protocols and plans, they have a brochure and protocol nutritional plan, one for leaky gut, which they call RepairVite. RepairVite is a dietary protocol and supplement protocol for leaky gut. They have another one for small intestinal bacterial overgrowth, SIBO. And then they have another one for loss of tolerance, mucosal health. That's where the strategy of like blending a shake and using short-chain fatty acids, that's really emphasized in this one. And these brochures are to use with your patients to teach them about that, and it tells them how to take the supplements and the protocol we designed very specific for each of those mechanisms, the web of what's involved with those mechanisms. I don't have time to go into all that detail with you, but I just want to share with you that they're available to you. You can get copies in the back, and if you're interested in having it made very simple for you, where you just hand the patients the brochure and they can read about it and implement protocols, it's all designed, okay? But I do want to make sure you guys understand how to clinically pick up the difference between leaky gut, loss of tolerance, and SIBO. Okay, so leaky gut, usually if someone comes in, they've had stress to their GI tract, like they've been under a lot of stress themselves, they had an infection, the diet's bad, they have joint pain, they have pain all over their body, they're inflamed. That strongly suggests maybe like a leaky gut history. That's different than someone who had SIBO. Patient that comes in with SIBO is like, I can't eat vegetables. The little fiber mix you want to make with my Vitamix makes me distended. As a matter of fact, anything I eat makes me bloated and distended all the time. If I eat a carrot, I'm totally bloated. That is small intestinal bacterial overgrowth. You guys understand the difference between the two? Okay. Now, you guys, a lot of inflammatory gut conditions lead to SIBO because the inflammatory process actually destroys the enteric nervous system. All the nerves around the gut that control motility, they're called the migrating motor complexes. And when you can't move your food and you lose the control neurologically to valves because the inflammation destroyed the nerves in the gut, and you can't control the ileocecal valve, then bacteria that's in the colon translocates to the small intestine, and then you have small intestinal bacterial overgrowth. Small intestinal bacterial overgrowth, for the most part, is translocation of bacteria. It's not like they got infected with bacteria, now it's in their colon. It's this loss of tone in their gut that leads to it. So when you see someone who now has SIBO, they're much worse. They've progressed. They now probably have an inflammatory gut. Now, SIBO can be caused by other things like antacids and other mechanisms like surgery, but your chronically inflamed gut person who's always had leaky gut can eventually end up with things like SIBO, okay? Now, then you have mucosal tolerance issues. That's when someone comes in and they have reactions to all different types of foods, and they have a food sensitivity panel, everything is sensitive and positive. That's a loss of tolerance, okay? So here's the scenario. Someone comes in and goes, I don't know what to eat anymore. Everything I eat causes a reaction. Did a food sensitivity panel to find out what I could eat? Everything shows a positive. That's not just SIBO or leaky gut. That's loss of tolerance. So what does loss of tolerance mean? Loss of tolerance means they probably have leaky gut, but they also have overactive dendritic cells. They have Tregs that are dysfunctioning. They don't have diversity in their microbiome. They probably are deficient in butyrate production in their colon. That is loss of tolerance. It's much more than just leaky gut. Everybody with me? Like the concepts? Okay. So you guys, if you guys want to use these as resources or check these out, they're available to you. They can help you educate your patients. You can read about them if you're not familiar with them, just for yourself. And then they come with dietary recommendations, complete protocols with how often they take the supplements. And these are in your notes, so you guys can read more about the products that are each of these formulas. Everything that is made by Apex is designed for the really sick, very sensitive, can't handle gluten, can't handle dairy, can't handle artificial flavors. It has to be made in a facility that's spotless and clean with no triggers or proteins or any other things made in them to really make sure that you have no problem with your chronically immune-sensitive patient. Okay? All right. Now, for the last few minutes I have here, I want to go into a new panel that Cyrex has made, which is a mucosal IgA panel. You can quickly screen the gut mucosa with a saliva test. How many of you guys do salivary cortisol test or salivary adrenal test or hormone test? A few of you do? Okay. This is the same type of test. Patient gets a test kit, they collect saliva, they send it to the lab. And with saliva, you can measure IgA. IgA is the main immunoglobulin for the gut mucosa, and it's a very reliable way to look at what's going on with the gut. So Cyrex has this test, and it's a simple saliva test, and it measures things. This is what's on there. LPS, remember LPS is which we start to release when you have leaky gut. It has tight junction proteins, occludin, zonulin, actomyosin, tight junction proteins. So if these show up, any of these three, LPS, occludin, zonulin, or actomyosin, that suggests that they have intestinal permeability. ASCA, ANCA, or markers for autoimmunity to the gut, that is very progressed inflammation in the gut. That means they're having an autoimmune progressive inflammatory disorder in the gut. Calprotectin is a marker for inflammation in the gut. Transglutaminase 2 is the screen for a celiac response in the gut. very serious gluten sensitivity responses. And then alpha-gliadin, gamma-gliadin, glutenin, wheat-germ-agglutinin, and gluteomorphin are all different fractions of the gluten epitope, the protein structure. So it's a very good screen for gluten sensitivity. Many times you'll miss gluten sensitivity if you only check gliadin antibodies. You got to check the spectrum of different branches of the gluten proteome to find it. They also check caseomorphin and alpha-beta casein, which are there for reactions to milk proteins. And they check the most common reactive foods for the gut: egg, soy, corn. They're all there. Aflatoxin is mold that you see typically in food that's stored in bins. So all the bins at Whole Foods with nuts and seeds and all those things. Nuts and seeds being the most common source of aflatoxins for people. And then they also check for chemical reactions in the gut: bisphenol A, mercury, and heavy metals. Now, these are not metal quantities. These are measuring mucosal immune responses to chemicals. This means that their immune system is reacting to chemicals, not that they have high levels in their system. Okay? It means they've lost their chemical tolerance when you see these to show up. Okay? Now, if someone has BPA reactions, do you think it's a good idea to drink out of plastic bottles? Or no. So you can remove the trigger the best you can, but at the end of the day, it's a marker. As you improve their gut tolerance, you see these chemical reactions go away, even if you haven't got rid of all the exposure itself. And then they check myelin basic protein in the mucosal pattern. Why do you think they check that? Because there's such a direct connection between gut on fire, brain on fire. You want to see if your patients that have mucosal problems have progressed to brain inflammation. They also check blood-brain barrier protein, so to see if their blood-brain barrier proteins are breakdown. And then they check for a common viral virus and then just general immune complexes. So with a quick saliva test, you can screen if they have leaky gut, sensitivities to milk, egg, dairy, soy, if they have chemical reactivity, if there are inflammations in their brain, if their blood-brain is broken down. Very easy. Right? It's the $350 test, I believe, to do the test. So it's a very quick way to screen patients for mucosal immunity. Now let me show you some samples. What if you guys see a panel that looks like this? What are you guys seeing here? So let me explain these lab ranges for you. So all the markers I just went over with you with this chart. This is the actual printout of a lab. Now green represents the normal reference range. Then you have yellow, which is equivocal, and then red. The yellow area, the equivocal range, the lab defines as 1 standard deviation from the normal, the mean. Okay? Red is 2 standard deviations. Remember the bell curve? The end of the tail, that's your red. That's your 2 standard deviations away. The yellow is 1 standard deviation away. Yellow is still clinically relevant. You can't just wait for the end of the tail. For immunological issues, like inflammation isn't all good or bad. Degrees matter. Okay? So clinically, the yellow or red is relevant to you. If you see yellow or red, think of that as clinically positive. Okay? You want your patients to be in the green range. Now, with this one, you're seeing something kind of unique. You're seeing what? Less than markers? You guys see that all over the place? Okay, so remember, these are all SIGA tests. So what does this suggest? This is an SIGA deficiency. They don't have enough immunoglobulins. When people get really immune compromised, their mucosal immunity gets plummeted. They drop their SIGA count. So I was speaking to the medical director at Cyrex on Tuesday. I go, on the samples you've gotten so far, what percentage of your population you're seeing have complete loss of SIGA? He said about 1 to 2%. Just to give you an idea. So you might see, if you do 100 of these, you might see 1 or 2 people show up with this. Now, is this clinically relevant to you? Yes. It means, like, not only, like, first of all, you can't use this, you don't know what these antigens mean because they don't have the immune system to show it. Now, from this point on, you could do a total SIGA count. Cyrex also offers that, and if that's, you don't want to repeat this test until that goes back up. So then your total SIGA becomes your marker you want to see improve over time. Okay, so you're going to have patients that have total immune compromise at times with these mucosal issues. All right. Now, let's go into another case. How about this one? Normal. They do exist. If you see one of these, the key thing to do here is to print it out and have them tape it on their fridge. And like a good report card, and you just, they're awesome. Okay? That's the ideal response. And the goal is for you to get your patient's test result. Whatever they come up with that's abnormal is their baseline, and ultimately you want to see those levels that are in the red and yellow go into the green. Okay? Now how about something like this? Okay, well now you've got some things out of range. So you see LPS out of range, you see occludin-zonuline out of range, you see actomycin out of range. So this tells you have markers for leaky gut. You guys all see that? So this person has some intestinal permeability showing up there. Now they have ASCA-ANCA antibodies. So those are autoantibodies to their own intestines. This is way more severe. Because when you see ASCA-ANCA antibodies, that means they're probably going to have chronic gut issues forever. That their autoimmune response is turned on to their own gut. So you wouldn't expect them to like jump out and do jumping jacks just because you put them on some supplements. This is going to be an ongoing battle. It gives you an idea of the extent of their inflammatory condition of their gut. ASCA antibody is always a progress sign. And then as you go down here, you see that they have this marker here, gamma gliadin, so some gluten sensitivity, glutamorphin, those are gluten sensitivity markers, some reactions against corn, aflatoxin. So you definitely want them to not have nuts or seeds because they're typically stored compounds that may have aflatoxins in them. Then you see some reactions against chemicals, mercury, and you see their blood-brain barrier breached. Is that good? No. So you see a blood-brain barrier breach. That's a big problem that you have there. And you see the gut barrier breach. So what would you do? Well, obviously the food triggers you remove. The chemical triggers, you can't really get rid of all mercury and heavy metals in their body. And it may not be a good idea to chelate them or do anything like that right now. Because why? Their immune system is reacting against it. If you start pulling that stuff out of their tissue, you're going to cause a severe inflammatory gut response. You ever see patients that try to get rid of metals and they get majorly worse? They're getting worse because their immune system is going crazy when they're exposed to those triggers. You got to make sure you fix their tolerance first before you try to remove this stuff. Okay? So now their blood-brain barrier is impacted, the gut barrier is impacted. So you can do you definitely want to consider things like enterovite, short-chain fatty acids, glutathione. Those things are critical for blood-brain barriers, gut barriers. Now you could do things like the Repairvite protocol. You can do, if they come in and say, hey, listen, I can't handle any plant fibers, you might progress and do the SIBO protocol, right? You might do the mucosal tolerance protocol if you feel like they progress to that point. So your clinical judgment is going to also based on their symptoms, whether how you treat them. But the key point is this is their baseline, and then you do a protocol, and maybe in 2 to 3 months you redo the test and see where they are. And you want to see them start to head into the green. Okay? Let's see, how about this one here? What do you guys see with this one? Well, we see definitely out of range. We have the occludin-zonuline out of the range. LPS is high. So we know we have the intestinal permeability, some inflammation in the gut. We definitely see reactions against gliadin, corn. Bisphenol A is showing up, so they're reacting against chemical. So drinking out of coffee lids is a major source of BPA exposure. Okay, because the heat releases the BPA. Beware of that. Heating foods and plastic compounds. Some restaurants are not cooking, like high-end restaurants are cooking and boiling everything in plastic bags. That's not a good idea for people to have BPA reactions. It can really promote their inflammatory gut response. And then you're seeing the blood-brain barrier antibodies, so you have some mucosal immunity, right? I mean, it's a lot of information from a quick saliva test. You're looking at blood-brain barrier, gut barrier, major food proteins, reactions to chemical loss of tolerance, very useful. Okay, how about this one here, 5? Wow. With that question out of range, leaky gut markers, okay? And then as you look down here, again, some chemical reactivity reactions. Let me move on, that's not the last one. How about this one? Not so bad. You see a little bit of reactions to milk proteins and egg. Aflatoxins. They don't have markers for permeability for the gut or the blood-brain barrier or severe inflammatory markers for the gut. Just some reactions to milk and egg. You guys, you'd be surprised. Some people, you just remove like a main protein like that, like A protein out of their diet, and they have tremendous change in their energy and their function. I mean, and the most common ones for mucosal responses are milk, egg, soy, corn. Okay. How about this one here? Yeah. Yeah. No? Now you guys see, what's the key thing with this? They're all out of range, like way out of range. Right now, listen, look at this example and compare it to this one. What's the difference between those two? severity, but they're totally both out of range, right? Okay. Now, no, not this. These are two different tests. Okay, so what you're seeing here is total loss of tolerance. Do you guys understand that? Yeah. Okay, now, people do have total loss of tolerance. However, if you guys see everything totally outside the range like that, like this, there's also the potential for an infection causing polyreactivity. Sometimes when people have a very acute infectious agent in their gut, you see all the counts go up, okay? Now, it could also show up in just some of them off the range. They're not all of them greater than, but if you see it greater than like this, you strongly suggest that. One of the ways, extra steps you can take to see to kind of rule this out, if you guys see a pattern like this, you definitely want to look at your blood eosinophils. And if the eosinophils are also off the chart, you probably have a gut infection, causing a polyreactivity, immune system's going crazy. They're still reacting to all these things. They're making antibodies and reacting to all these things. It's still clinically relevant. But there'll be many people that don't have polyreactivity and they lose their tolerance like this. Okay? Now, when I spoke to the medical director at Cyrex, I go, what percentage of your patients have this? The samples that the lab has gone so far have this. He goes, it's about 5%. Which to me, I thought was shocked. I would expect to see much more of this. Okay? So if you're doing these tests, if you do 100 tests, you might have 1 or 2, based on the stats so far that they have, 1 or 2 may have the total SIJ deficiency, and then maybe about 5 out of 100 that are going to be complete loss of tolerance. Okay? And they'll tell you. You'll see. They can't react. They'll eat every food. They react to everything they eat. It's a problem for them.
So okay? What's your strategy with those patients?
So what's the strategy? The strategy is to improve their tolerance. So I would do this. I would do the complete mucosal program, put them on high amounts of butyrate, get them to diversify their foods, eat a lot of different plant-based compounds, load them up on trisomal glutathione, get their glutathione levels as high as possible. Make sure that even though they react to every food, diversify and get as many plant vegetables in, so what? Get that in to get their microbiome, fuel them with butyrate as they develop their microbiome, and try to turn down those Treg cells and dendritic cells and fix the leaky gut, all the things you need to do. And then repeat the test in 2 to 4 months and see if they're getting out of that range. Now, what if you guys see something like this? It's the same thing. It's just not as progressed. And some you might get back some that are some in the yellow, some in the red, but almost reacting to everything. Those are loss of tolerance. You guys, there are a lot of people that lose their tolerance and they react to all food proteins and they have leaky gut and the blood-brain breaks down and so forth. Okay, and how about this one here? So what do you guys see here? You guys are seeing some reactions. Intestinal permeability, a little bit up here. Let me just switch it to here. Some mucosal response to gluten, eggs and milk, heavy metals, some immune reactivity. Now, I'll tell you what I do when I look at these panels. The key thing I do is I go, do they have, first of all, do they have complete SIGI deficiency? Are they totally depleted or not? And so I look to see if everything's below range. Then I look to see, do they have complete loss of tolerance where they react to almost everything? That's my first 2 things I like to look at. Then I look and then I want to see what's going on with them. So most people will have some things show up here and there, right? So if they have leaky gut, my next question is, do they have a leaky blood-brain barrier? If I see that, I'm a little bit more concerned. And if they have a leaky blood-brain barrier, my next question is, has it impacted their myelin immune response? If I see myelin, I'm way more concerned, because now I'm seeing their gut's on fire, their brain's on fire. It's much more serious than someone just has leaky gut. Okay? The other thing I look at is ASCA-ANCA antibodies, which are antibodies to the own gut mucosa. And if that's positive, I know they have some autoimmunity going in their gut, so the prognosis with them is much worse. Then I get a general idea, because you guys have 10 patients with similar GI symptoms. You don't know what stage they're on, if it's gone to the brain, if their blood-brain barrier, gut barrier is broken, if there's inflammation in the brain, if any of those things are going on until you see that system. Makes sense? Until you see the big picture. So this is a great test. If you haven't used it in your office, nothing is easier than handing a patient a saliva test kit, have them go home, collect the samples. When I give out saliva test kits, a lot of times I'll have patients just collect the sample for me while they're there, and then we just send it out. Because you'll see how many patients will take it home and not send it out. So it takes just a couple minutes to have them fill it out. Just say, collect the sample, and then you can have your staff just make sure they get the credit card information, all that right, and just get it done, and then you get the information pretty quickly. Okay, a couple weeks. It's about $350 for the test, and you have to fill a tube of saliva to get a change. Okay, so here's the recap, review of concepts. I just have 5 minutes. Let me just put it all together for you. Okay, so here's the main concepts. The main concept is number 1. What we were doing with patients that were chronically sick, just putting them on leaky gut and just being okay with the fact they're off gluten and dairy and soy and inflammatory foods, and that list of foods that they have to be off was okay, and not paying attention to how diverse their plant foods are was, for me, I don't know about you, but for me, an area where I was missing a key piece of them getting better, right? So we know just eliminating gluten and being on a leak gut protocol is not enough for many people, right? And if you look at the research, it's really more about, as people get sicker in reactive foods, is that they lose their tolerance. And when they lose their tolerance, that means they get leaky gut, their dendritic cells get overreactive, their Treg cells don't work, and they have all these significant immune reactive responses for food proteins. The key thing that turns these things off is a diverse gut. And a diverse gut microbiota makes bacteria that are diverse, which then increases the potential to make more butyrate. Butyrate then provides fuel to the bacteria to be more diverse, but butyrate is the key signaling agent for pathways for metabolism and for blocking inflammation, for tolerance. So using butyrate has a lot of clinical effects in addition to diversifying the diet. So that's a key clinical takeaway. And then inflammation in the gut doesn't allow the gut to diversify and produce bacteria and promotes leaky gut. So the two key nutritional takeaways are glutathione and short-chain fatty acids. And as people progress down this chain, they may have SIBO, which they react to every single every single starch. So that's a different dietary restriction. There's a brochure to help you with that. People could have complete loss of tolerance. They have another brochure for that. And people can just have leaky gut. So those are the things to really consider. Now, you can use a saliva test very quickly in your office to really screen for mucosal health. You guys saw Ray 14, very easy to interpret. And you can use that in combination with the information to make a change. For most of the people that you guys will do the Ray 14, the saliva test on, you're going to see a lot of people your key issue is to fix their tolerance. It's not just to remove like wheat or milk. It's like you got to get in there and fix their tolerance and support them and then use that as their baseline, the first test as their baseline and the follow-up test to see if they're getting better. Okay? I will stick around if you have any questions. I don't want to go over. I know a lot of you guys have to go back to your practices. Thank you for coming. Hopefully you got something useful you can use. Thank you.